Okay, so this is a little bit of an odd week. We're going to be talking about two concepts, the static keyword and command line arguments, that are really standalone topics. And then after that, we're going to be transitioning into a new topic and in fact, into a new part of the course. And we're going to move into talking about searching and sorting, which is less about programming and more about computer science. So this lecture is about the static keyword. The next lecture will be about command line arguments. And then after that, you will have all of the information you need to understand the method header for the main method. Okay, so we know what public is. We'll talk about what static is. We know what void, the void return type means. We know what main means. We know what the main method is. And then there's the string args. We now know that those square brackets are indicates it's an array of strings. And when we talk about command line arguments, we will talk about what is the purpose of that array of strings. So together, this lecture and the next lecture kind of complete your knowledge or what you need to know to understand the method header for the main method. Okay, so we're going to talk about the static keyword. I'm going to begin by giving you a definition of what static means. And then we're going to look at lots of different examples and different applications or uses of the static keyword. And one maybe piece of cautionary advice I might give is that I think the definition of what static is quite simple. But then when you go to use the static keyword, there's all of these different ways of using it, or at least it feels that way. And then the static keyword interacts with private, it interacts with public, you can use on variables methods. So although the definition is very simple, the use of static can feel confusing, and it feels like each use of static is a new way of using it, and it doesn't seem like they're related. So maybe one piece of advice I would give is, from this lecture, I think the most important thing is the definition, really making sure that you understand the definition for static and don't get lost in all the examples. And then when you're programming, if you understand the meaning or the definition of static, then when you're programming, you can, starting with the definition, you can kind of reason your way through how to use it. Okay, so make sure that you understand the definition and don't get lost in the examples. Okay, or said differently, the definition will help keep you anchored so you can make your way through these seemingly different examples. Okay, that probably didn't make any sense. Maybe I'll repeat that at the end, and maybe it will make a bit more sense. Okay, so let's start with the actual definition of static. What is static? So static methods and static variables are associated with the class. They are not associated with an object of that class. Okay, so static methods and static variables are associated with the class. They are not associated with an object of that class. Okay. So let's begin by talking about static variables, and we'll see an example of what does it mean for something to be associated with a class as opposed to being associated with an object of that class. Okay, so here's a very simple Java class. I called it test. It has two instance variables, total and counter. Total is being initialized up top here. Counter is being initialized in the constructor, and then we are incrementing total. This class doesn't really have much meaning to it beyond I kind of artificially created it for the purposes of this lecture. Okay, before we talk about static, I want to spend a little bit of time on kind of a detour. I just want to talk about one thing I'm seeing in a lot of our code that I want to address. Okay, these are two instance variables, total and counter. Total has been initialized up top. Counter has been initialized in the constructor. I'm seeing a lot of students do this. So sometimes you will initialize variables up top, sometimes you initialize variables in the constructor. Okay, it is totally valid in Java to initialize your instance variables up top. And in fact, that is more natural for you because we almost always declare and initialize our variables at the same time. So this feels very natural. However, I have been encouraging strongly the practice of initializing your instance variables in the constructor. Okay, and the reason why is, let's say that you have a class with a lot of instance variables. Let's say I've got maybe 15, 20 instance variables. Some of them I initialize up top here, but some of them I have to wait to initialize them until the constructor. Okay, in particular, we might need the user to pass in some value, like the name of the organism or the number of sides of the die. So for certain instance variables, I truly have to wait until the constructor to initialize them. Okay, I can't initialize them up top. Okay, so if some of my instance variables are initialized up top and some of them are initialized in the constructor, and I've got a lot of them, chances are you're going to overlook a variable. Okay, chances are of those 20 instance variables, one of them is not going to get initialized. Okay, so if you can be more consistent, then typically in programming, that's a better thing. So I would say either initialize all of your instance variables up top or initialize all of your instance variables in the constructor. Don't try and do half and half. That's just a recipe for overlooking a variable. So if you're either going to initialize them all up top or all in the constructor, right, then I would say it's better to initialize them in the constructor because for certain instance variables, you have to wait to the constructor to initialize them. Okay, so if you're going to choose either doing them all up here or doing them all in the constructor, initialize them all in the constructor. Okay, so I just want to address that because I do see people doing both. So sometimes you initialize up here, sometimes you initialize down there. It kind of depends upon your mood, the day of the week, what you had for lunch, whatever. And I just want to caution you, I really think it's better to initialize all your instance variables in the constructor so that you have one place where you look to see and to check that everything has been initialized, as opposed to having distributed the initialization. Some got initialized up top, some got initialized down the bottom. I kind of feel like that's a recipe for making a mistake. Okay, that's that. I just want to address it. Let's get back on topic, static. Okay. Okay, this is a very simple class. There's not much interesting about it. And we have written a bunch of these types of classes. Once you've written your class, then in your main method, you can create objects of type test. So I could say test1 equals new test. And test2 equals new test. And when we create these objects, each one, so I'm going to draw them as circles. So this is our test1 object. This is our test2 object. And each object gets its own copy of the instance variables. Okay, so test1 has a copy, right, its own copy of total, which starts out at 0, and it has its own copy of counter, okay, which also starts out at 0, and then we increment total to 1. Similarly, test2 has its own copy of total, and it has its own copy of counter. It's initialized to 0, so on and so forth. This is kind of par for the course. This is what we've been doing. Write my class, use my class. And each object gets its own copy of the instance variables. That is what determines the state, right? The state of these variables is the state of the object. One way of saying this is that these variables are associated with the object that they're in. Okay, and kind of going back to our definition, right? Normal instance variables are associated with an object. Okay, so each of these instance variables is associated with a particular object. Now, what happens if I have the exact same code and now the only difference is I made one of these variables static? Okay, so we're going to see, I'm going to tell you, right, a very simple change, but it actually has a pretty profound impact. Okay, so here's the picture that I'm going to draw to illustrate what happens when we make one of these variables static. So here's our class, and I kind of am only showing the variables. And then here I'm going to create 3 test objects. Okay, so, okay, because I made this variable total static, it is associated with the class, and thus I'm showing it up here in the class. It is not associated with the objects. Thus, you'll notice that these objects no longer have their own copy of the total variable. There's only one copy, and it exists up here in the class. So in my main method, when I say test1 equals new test, right? So first of all, this starts off at 0. So when I say test1 equals new test, right, counter gets set to 0, and then we increment, right? We have this increment statement here. So total plus plus. So total gets incremented, and it's now 1. Okay, then I say test2 equals new test. Counter gets initialized to 0, and I increment total to 2. Okay, last but not least, test3 equals new test. Counter gets initialized to 0, total is incremented to 3. Okay, and every time I create a new test object, the object gets its own copy of the instance variable counter, but there's only ever one copy of the total variable. And that's because it's static. A static variable is associated with the class. It is not associated with the objects. Now, why? Why might I create a static variable? I'm showing a really good reason right here. Anytime you have a piece of information that either A, is a global piece of information that you want to keep track of, or B, it doesn't really make sense to replicate it inside of each object, then you should make it static. Okay, here total, what it's doing is it's keeping track of the total number of test objects that we've created. And every time you create a new test object, this gets incremented. Okay, so total is this kind of global piece of information that we want to keep track of, which is how many test objects have I created? So it wouldn't make sense to replicate it inside of each object. Instead, it makes sense to make it static so that it is a global piece of information associated with the class, right? And then we can use it to keep track of how many objects have we created so far. So 2 things. 1, this illustrates that definition. A static variable is associated with the class. It is not associated with the object. 2, uses or reasons you might create a variable to be static include things like I want to keep track of some global piece of information like a total count, or it doesn't make sense for each object to have its own copy of that particular variable. Okay, and here I'm just driving it home. Each object has its own copy of the instance variables, but there's only one copy of the static variable, and that exists up here at the class level. Okay, so let's go through and make minor changes and just ask ourselves what would happen if we made these minor changes. So here, the only change that I've made is instead of saying total plus plus, I'm now saying this dot total plus plus. And my question to you is, what do you think would happen? Is this an okay piece of syntax, or would it cause a compiler error? If it didn't cause a compiler error, would it cause a runtime error? Right? If it didn't cause a runtime error, is the effect this dot total plus plus the same as just saying total plus plus? Okay, so pause the video and try and predict what do you think would happen. Okay, so in this case, it would compile. So yes. Sometimes, so this wouldn't happen in BlueJ, but in a professional IDE, there's lots out there like Sublime, Eclipse, NetBeans, all this stuff. You would often get a warning. Okay, so you would get a warning when you compiled. So this isn't going to throw an error per se, but you would get a warning, and the warning would say something like, you shouldn't reference a static variable from a non-static context. Okay, you shouldn't reference a static variable from a non-static context. What this means is if you use this dot total, in terms of the syntax, it's fine. This refers to this object. Inside the object, there's a static variable called total, and you want to increment it. The only problem is by saying this, it seems like total is an instance variable, and it's not an instance variable. So anyone looking at this piece of code, this line of code, is going to be misled. It's very misleading. So that error message, like, referencing a static variable in a non-static way or in a non-static context, what it's trying to say is, it's a little misleading. You can do it, but it really looks like total is an instance variable, and it's not an instance variable. Okay, so in BlueJ, you won't get a warning. In a professional IDE, you often will get a warning. You can do it, but it's very, very bad. It's very, very bad programming practice because it's very misleading. Okay, what if I had said total? So now I'm back to just total plus plus. What if I had said total equals 0? Okay, what if I had inserted this line of code into the constructor? Okay, so you should, again, pause the video and predict what do you think adding this one line of code will do. Okay, so if we added this one line of code, then in our main method, okay, so again, we have our class test. And in our class, we have this static variable total. Then if we were to create a new object, let's say we said, test1 equals new test, what would happen? So total would get set to 0. Then counter would get set to 0. And then we would increment total to 1 because we just created one object. If we created a second object, so test2, when the constructor runs, we'll set total back to 0. Then counter gets initialized to 0. And then we increment it to 1 again. So by setting total equal to 0 in the constructor, we have a logical error. Instead of total counting the number of objects we've created, we're resetting it to 0 each time, and it will never get beyond 1. Okay, so this is a logical error. Okay, last but not least, this is something interesting. What if I declared total to be public? Okay, and as I said kind of at the beginning of this lecture, the static keyword interacts with private and public in ways that maybe seem unrelated to the definition. So let's look at an example of this. Usually our variables are private, but we could have them be public. If I had a public static variable, what that means, in fact, forget it. If I had a public variable, period, if you have a public instance variable, if you have a public static variable, what that means is in my main method, okay, if someone was to create, well, let's just say this. In my main method, okay, in some other class, so let's call this test controller, someone writing this class can access this variable now because I've made it public. Okay, and what that means is that they can store something in it, they can modify the value, they could print it, they can basically do whatever they want because it's public. So we could do things like set total to 1,000,000 or set total to -11. We could print total. By making it public, it means that from outside of the class in another class, we are able to access that variable. In fact, if we made counter public, again, from another class, we would be able to reach inside and we would be able to use the dot operator to change the value of counter. Now, what does that look like for a static variable? How would I actually access a public static variable from a different class? And this syntax is going to look very different from anything we've done before. So let's say that in this main method, I want to set total to 100. There's not really a good reason, but let's just do it. Now, total is not associated with an object. It's associated with the class. That's what it means to be static, right? It's associated with the class, not the object. So if I want to access this variable, I use the name of the class. I would say test dot total equals 100. So this is the first time ever that we've used the dot operator, not on an object, but on the class itself. And that's because total is a static variable. It's associated with the class. It's not associated with the object. Now, contrast that if we decided to make our instance variable public as well. So let's make this public too. And again, let's say that we wanted to set counter to -14. In order to do that, we would first have to create an object, and then we could access its counter variable. Okay, so I would first have to say, oops, right, test 1 equals new test. And then I could say test 1 dot counter equals -14. So notice that both of these are public, meaning both can be accessed outside of the class, but the way we access them is quite different. Total is static, so we use the name of the class. Counter is an instance variable, so we have to create an object, and then we use the name of the object. Now, one last word of warning, if you are going to make a variable, and this is a piece of advice for static or an instance variable, doesn't matter. If you are going to make a variable public, you probably want to make it final as well. Okay, and going all the way back to like week 2 in the semester, final means once I give it a value, we can never change it. So if you are going to make a variable static or instance variable public, then you probably want to make it final as well. Otherwise, you're allowing anyone from any other class to just set that variable to whatever they want to set it to. Okay, so at the end of this lecture, we will see examples of public static variables, but they will be public static final variables. Okay, said differently, in Java, there are lots of examples of public static final variables that cannot be changed. I can't think of an example of a public static non-final variable. Those tend to be a little iffy because you're really allowing anyone to do anything they want, usually not a good idea. Okay, so that's it for static variables. Again, what is a static variable? It means that there's only one variable that is associated with the class, not the object. Static variables are modifiable by all objects of that class, as we saw. And if you want to make it accessible outside of the class, if you want your static variable to be public, you really should consider making it final and not letting people do what they want. Okay, so let's move on to static methods. So again, a static method also is associated with the class. It's not associated with the object. Okay, it's associated with the class. It's not associated with the object. Okay, so here we have our two variables, one that's static, one that is not static. And I've created two methods. This is a static method. This is a non-static method. Here's an example. The first time we're seeing that in a single class, not only is it possible to have static and non-static variables mixed together, it's also possible to have a class that has static methods and non-static methods mixed together. Up until this point, we've done a really good job of separating it. Either we have a class that has non-static methods, like our die class or organism class, or we have a class like our controller or tester classes that has a main method that's static, and any other method we put in there is static. And we've done a really good job of separating those two worlds. But in fact, you can have a class that has both static and non-static methods. Now, in this case, we're going to talk about two things. One, inside of the static method, what variables are we allowed to access? And 2, from our main method, how would I call the static method? It's not quite clear how we would do that. So let's start with, inside this method, what variables are we allowed to touch? Now, inside of this non-static method, this is kind of just a normal instance method, maybe equals to string, kind of a basic method that we've been writing. Inside of here, you can access, meaning you can update or print or change either of these variables. Okay, so I could say something like system.out.print total equals total. And I could say maybe counter plus plus system, let's move this, system.out.print counter equals counter. So from inside this normal instance method, and I'm using the word instance method to indicate it's kind of a non-static method, we could access either of those variables. And maybe that shouldn't be surprising, because from the constructor, which is just a normal method, right? It's a normal non-static method, we were able to access both of those variables as well. So maybe this isn't as surprising. Really, the difference comes in here from the static method. The static method can only access, update, modify, print, change static variables. Okay, a static method cannot access non-static variables. So here's a line of code that would actually trigger a compile time error. Counter plus plus. Counter is a non-static instance variable. It's associated with an object, but in a static method, there is no object. And so trying to update, increment, print, counter is in fact going to give you a compile time error. And similar to before, this error is going to be something like, unable to access or unable to reference a non-static variable in a static context. Okay, so the error message will make it clear, like, you're in a static world, you're in a static context, and you're trying to access something that isn't static, and you can't do that. Okay, and the reason you can't do that is there's no object here, right? The static method is associated with the class. There's no object. And if there's no object, then there's no counter. But as maybe your intuition would tell you, you can access, print, update, modify, whatever, static variables. So it would be completely okay to say system.out.print and then print the value of total. So maybe a few different takeaways. One, in a class, you can mix static and non-static methods. We really haven't done that up to this point, but it is possible. 2, when you do that, in each method, you kind of have to remember what world or what context you're operating from. So for example, an instance method here, I can access instance variables, I can access static variables, but in a static method, I cannot access instance variables because there's no object. Right? I can only access static variables. Last but not least, okay, so here's my example, and this is my analogous picture here. So when we create these test objects, they get a copy, right? Each of them has a copy of its own instance variable, and they get a copy of all the instance methods, but the static method is not replicated or is not copied in each of these objects. In the same way that the static variable total here, there's only one copy and it exists in the class, not in the objects. In the same way, the static method, there's only one copy of this method and it's associated with the class. It's not associated with any particular object. Okay, so this picture is kind of the analog of our earlier picture, but now we're incorporating methods as well. Okay, how would I actually call this method? So again, for our instance method, it's pretty much par for the course. We create a new object, let's call it test1, and then we'd say test1.instance method. And this is kind of the syntax we've been using all semester long. However, for our static method, it's associated with the class. So we would say test, this is the name of the class, dot static method. Okay, and also we would say test dot, right, total. Okay, so for any static variable or method, if you want to access it outside of the class, well, one, it has to be public, but if it's public, you use the name of the class because there's no object, there's just the class. Okay, so kind of summarizing static methods. Again, static methods are associated with the class. From inside the class, you can call them as usual, but from outside of the class, you need to use the class name to call them. I guess also on this sheet of summary, like this slide here, I should also say, in a static method, you can only access static variables. Okay, now I want to look at some examples. So java.lang.math and java.lang.integer. So these are two classes that are part of the Java standard library. These are classes written by other people. They probably wrote them 20 years ago. And these are classes that we can use. If you did want to use either of these classes, you would have to import java.lang.math or import java.lang.integer. I want to look at these classes because these have examples of static methods and static variables. Okay, so let's look at java.lang.math. So you can do java.math. It's the very first link here. Okay, so the class math contains methods for performing basic numeric operations such as elementary exponentiation, logarithms, square root, trigonometric functions, so on and so forth. I think it actually says, no, okay. If we look at this class, it has two fields, which is another way of saying two variables defined at the class level. Both of these variables are static. The first variable is e, right? This holds the value of e, which is the base of the natural logarithms. Notice that it's final. Okay, so here's an example of a public static final variable called e, which holds the value of e, 2.71 dot 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 dot. It is final so that even though it's public, and if I need to use that value in my mathematical code, I can use it, but I cannot change it because it is final. The other one that it has, the other field is pi. So this holds the value of pi, so 3.1415 dot dot dot. Again, if we click on it, we see that this is also final. Okay, so both of these are static variables, so they're associated with the class. They're public so that you can use them, but they're also final, so you can't screw around with them. Also, this class has a bunch of methods. Notice over here, all of these methods are static. Okay, so this is a class full of static methods. The methods are just basic kind of math functions you might want to call. So there's an absolute value where you pass in a number and it returns the absolute value. It has arc, cosine, let's skip all that. Ceiling, so the ceiling of a number is if you take a number, it rounds it up to the nearest whole number. Floor then is kind of the opposite, it rounds it down to the nearest whole number. So the ceiling of 3.5 would be 4. The floor of 3.5 would be 3. Okay, you kind of think of your ceiling above you and your floor below you. Other interesting things it has, so you can take the log of a number. You can get the maximum of 2 numbers, so you pass an A or B and it returns whichever one is largest. The minimum of 2 numbers. Random, so here's another way of generating a random number. If you call this method, it returns a double between 0 or 1. Round, so as opposed to ceiling or floor, the round method will round you to whichever whole number is closest. So 3.9 would round up to 4, but 3.1 would round down to 3. So that's the round method. And there was one other one I thought, oh, square root and pow. Here we go. So this is the power method. Sorry, I hope you can see this. Basically, you'd pass in A and B, and it will compute A raised to the power B. So if you wanted to square something, you could pass in A, and then you'd pass in 2, and it would raise A to the second power. So this is the math class. What that means then is if we wanted to use any sort of method or use a variable from the math class, we would have to say, so this is in our main method, we could say something like math dot abs, okay. So maybe we say something like double temp equals math dot abs negative 4.5. So again, if you want to call any of these methods, or if you wanted to access one of the variables like math.py, the way that you do that is using the name of the class. Last but not least is the integer class that I wanted to look at. So Java integer, good enough. Okay, so this is an integer class. We talked about this. If you want to have an array list of integers, you can't use the primitive int. You have to use these wrapper classes, capital I integer. In addition to basically storing a single int, it actually has some static variables and some static methods. So some of the static variables max value. So this holds the maximum value that an integer can have, which is 2 raised to the 31st power minus 1 at somewhere around 2 billion. There's also a constant min value. This stores the lowest that an integer could ever store, which is negative 2 to the 31st. There's some other stuff. And then down here in the method table, notice that some of these methods are static, some of the methods are not static. So the static methods are like compare. If you pass in 2 integers, it will compare them numerically. It returns 0 if they're equal. It returns a negative number if x is smaller than y, and it returns a positive number if x is greater than y. Okay, so looking at this method here, compare, this isn't really a method that needs to be in the object, right? It's basically a standalone kind of short and sweet method. You give me 2 integers and I compare them. Okay, contrast that with if it was non-static, then we would only need 1 integer and we would take this integer and the other integer and compare them. But because it's non-static, we have to pass in both integers. Also, there's one important one here. Here, parse int. So this is a method that over the semester I've seen various people stumble into and kind of fall in love with and want to use. And now you can use it and understand what it's doing. Basically, oftentimes we need to convert from a string to an integer or from an integer to a string. Converting from a string to an integer, you can use this method. You can call parse int. So you would say integer, capital INTEGR dot parse int. You would pass in the string 4 and it would return the number 4. So this method converts from a string representation of a number to an actual number. Let's see, there are other static methods here, but they're not as easy to understand. So yeah, I think this is really the method that for our purposes is kind of the easiest and the most useful, which is parse int. Okay, so last but not least, I wanted to summarize as follows. So static means that the member, whether it's a variable or method, is associated with the class, not an object. To summarize, if you have an instance member, so you have an instance variable or an instance method, it can interact with other instance members. If you have an instance member like an instance variable or an instance method, it can interact with static variables. It can interact with static methods. Conversely, if you have a static member, so you have a static variable or static method, it can interact with other static members. This is the one relationship, though, that breaks. Static members cannot interact with instance members. Okay, so a static method cannot access, modify, update, print an instance variable. Okay, the static world is not allowed to reach out and touch the non-static object-oriented world. But the reverse relationship is possible. It is okay for the instance variable and the instance method, it's okay for the object-oriented world to reach out and touch the static world. Okay, so this summary here makes sure that you kind of understand each of these relationships, and in particular why this last one does not work. Okay, this has been a rather long variable. Let's finish up with just a very quick recap here. This is the definition of static. If nothing else, hold on to and make sure that you understand this definition. Static methods and variables are associated with a class, not an object. As an example, okay, in this picture, the instance variable counter, there's one copy for each object, but the static variable total, there's only one copy and it exists in the class, not in any object. Okay, similarly, for the static method, each object gets its own copy of the instance method, but the static method, there's only one copy and it's associated with the class, not the method, sorry, not the object. These are examples of code that other people have written that have static variables and static methods that are public. And if you wanted to use them, one, don't forget to import them. But again, you'd have to use the name of the class because there's no object. Okay, and last but not least, understanding that instance members can interact with instance members can interact with static members can interact with static members. But the one area where this relationship breaks down is static members cannot interact with instance members because there's no object. If you're in a static method, there's no object, so you can't refer to the instance variables. Okay, so that's the one part of the relationship that kind of breaks down. Okay, so this is a little bit of a longer lecture. Again, if there's anything you took from it, it's just a definition. And if you understand the definition, you can kind of reason your way through all of these different examples. There are other uses of static or other examples we could have looked at beyond the examples that we did. But at some point, all the different examples kind of become a little bit confusing and they all feel slightly different. And so we looked at the examples that we did and just center yourself or anchor yourself in the definition and you should be good to go. Okay, that is that.